Hi team, so tomorrow we've got short test number 2. Topics to be covered for the test start from where we left off for short test number 1. So we'll cover one-way ANOVA, two-way ANOVA, correlation, and the different types of regression. I know that we've also had lectures on chi-squared, but I'm not putting these on short test 2 as I have saved them for your final exam. Hopefully you've already been studying hard. However, as you make it to the final 24 hours before the test, I want to give you 4 quick tips to focus on. Tip number 1, you must know the research question that is actually being asked. In BI 206, we frame this in terms of our null hypothesis and our alternative hypothesis. Make sure you can give a specific null and alternative hypotheses for each of the examples listed here. For example, the alternative hypothesis for one-way ANOVA would be that the average weight of at least one of the fish species is significantly different than the other fish species. The null hypothesis for regression would be that there is no relationship between the amount of time spent studying for short test number 2 and the grade received on this test. Remember also that when it comes to a two-way ANOVA, you've got 3 null and 3 alternative hypotheses. Tip number 2, you must be able to tell me why you are choosing a particular type of test. In some cases, the research question will be given, so this will inherently guide you in the right direction. However, in other cases, it won't be given, and so you'll have to decide yourself. Looking at the type of data is also important, as you know that each different test can only be run on certain types of data, and in addition, the number of categories, factors, etc. must be taken into consideration. In some cases, you can only decide on the right test once you are able to check appropriate assumptions have been met. Looking at the R output, as we're about to discuss, will also outline the relevant steps and analysis that was undertaken. Tip number 3, when you're given R output, you must know which bits you should pay attention to. In the case of ANOVA, you'll be given an ANOVA table with 1 or 3 F statistics. Here you can see we've got the output for a two-way ANOVA. Make sure you know what each F statistic is testing and of course whether it's significant or not. As per usual, a p-value of 0.05 or less is what we're looking for. Now, if you do have a significant result in your F statistic for the ANOVA table, you will then need to look at 2 key post hoc tests, which are divided up into main effects and interactions. Again, have it straight in your head where you need to look when questions referring to these different components are asked. In the case of regression, your R output will look something like this. The test on the estimate for slope tells us whether our response variable is significantly affected by the dependent variable. The test on the estimate for the intercept tells us whether our regression line goes through 0. And of course, the 2 estimates A and B, so intercept and slope, these 2 estimates can be plugged into our regression equation, which in turn can be used for prediction. Another key part of the regression output is the adjusted R-squared value. Here you can see it equals 0.9118. Tip number 4, interpretation, and more specifically, an interpretive sentence, is essential in quantitative biology. It's not enough to collect the data or even to go one step further and run it through R. You must be able to summarize what the study found out. Make sure you have the structure of an interpretive sentence in your mind for each of the 4 different types of analyses that will be covered in short test number 2. Use the examples in the lecture materials as your guide. All right, I hope these 4 tips are helpful. I'll let you get back to studying. Good luck.